because I allowed some mistakes to happen because mistakes are beautiful and something to learn from. And so y'all need to pay attention and see where we might have made some mistakes. So first things first, this is an error that I see a lot of students making, especially today. I have x plus 3 squared, so they want to subtract 3. I get that, right? But I talked about this in a couple of groups. First off, what does it mean to square something? Multiply it by itself. So is it as simple as just subtracting 3? No. In fact, if you go through the idea of distribution, you're going to get x squared plus 6x plus 9 equals 121. First off, you probably don't know how to solve an equation like that. Second off, would I just be subtracting 3? No. And so remember, and this is why I said this earlier, identify the last operation being applied. What's happening to x first? Then, after adding by 3, it's being squared. So what do I need to undo first? Take that square root to undo the square. So, remember it's going to make an exponent of 1, so I'm left with x plus 3 equals what? 11. Square root of 121, okay, so 11. Okay. So what did y'all do from here? Subtract it by 3 on both sides. Create that 0. And x equals what? 8. Okay, does anybody want to push back on any of this or ask a question? No. Say it louder. Oh, what? Where did you get negative 8 from? Oh, you took a square root, so how many solutions do you need? 2? Oh, we need both to be true? No. Yes. Okay? So, well, one thing I will say, J1, when we're taking that square root, more than likely, almost every time, we're going to get 2 solutions. But I also want to bring up something that I saw Preston doing earlier. Can we use the calculator to help us check? Yes. Okay. Open up what type of page on your calculator? Alright, so open up a calculator page. So what am I going to type in to check if 8 and negative 8 are solutions? And I think the equation was x plus 3 squared equals 121. Alright, what am I going to substitute in for x? 8. Or negative 8. And so x plus 3 squared equals 121. Hey, that is true. So is 8 a solution? By the way, it's going to help if you actually type it into your calculator so that you get used to doing it more instead of just waiting on me to do it for you. So, hey, by the way, don't forget at this point, instead of having to retype the whole thing, what can I do? Right? I can scroll up and just hit enter, bring it down. Oh. Oh. It said false.
Oh, because sometimes it can wrong.
Okay, so, well, hold on. That's not the issue. I'll point this out. By the way, what's negative 8 plus 3? Negative 5. And what's negative 5 squared? Not 25, not 121. So here's a note that you need to pay attention to. I got a positive and a negative here when I took the square root. So remember, 11 squared is 121. What else squared would be 121? Negative 11? Test that in your calculator. See if that makes the equation true or false. Remember, you already have it typed out. You can just, okay? Remember, guys, be efficient with your calculators. You can just scroll up, highlight it, hit enter, and change that 8 to a negative 11. Or negative 14. Sorry, not negative 11. True. True! Ah. So this is a detail that we need to pay attention to. And so I'm glad, right? Mackenzie, at least remember, we needed 2 solutions. But when do we do a positive and a negative? As soon as you take the square root. As soon as you take the square root, you need a positive and negative. So that's when you're going to split it into into two equations. Because remember, the idea is 11 squared was 121, and negative 11 squared is 121. Okay? So we need to pay attention to that.
This one has two answers.
8 to negative 14. Remember, we already checked the negative 14. And not just answers. What are these answers called? Solutions. They make the equation true. Ooh, there we go. Thank you. So, I've already seen a bunch of us starting on C. And so I want to address a couple of mistakes here. I'm going to have y'all work on D. What do you think the most common thing that students want to do here is? They want to distribute. But remember, what does x minus 1 squared actually mean? So is it as simple as just distributing that tree inside? Remember, an exponent happens before multiplication, right? Say that louder, Chloe.
Times 1/3.
Remember, if I can use an inverse, then that's going to undo operations that are there. Multiplication is happening, right?
Yes.
Hey, what was the multiplicative inverse? It's also called the reciprocal. This is 3 divided by 1, multiplied by 1, divided by 3. That reciprocal there? Times 1 divided by 3. So which property of equality would this be? Which property of equality? Multiplication, property of equality. Keyshawn, the inverse is just this part. But because I multiplied by 1/3 on the right-hand side, I also had to do it on the left-hand side. Does that make sense? Okay. So, the whole point though is 3 divided by 3 is 1. By the way, if you didn't already know that, I would make this note. Multiplicative, inverse,
There's one.
well, not the identity is 1. What's the name of the inverse though? Reciprocal. Right? When you talk about that multiplicative inverse, you're talking about that reciprocal. Okay. So, 1/3 of 48? Oh, 16.
Oh,
1/3 of 48, we should have already done it, right? 16 equals, now?
Square root.
Once we get to that square, we need to recognize, take that square root. So 4 is equal to x minus 1, right? That's it?
No.
and
Halfway.
And what?
negative 4 is
Do I need to also write negative 4 is equal to x minus 1? Remember, it's when you take that square root. Because, hey, what is 4 squared? 16. What's negative 4 squared? 16. When you take that square root, that's when you need the positive and the negative. From here, all right, you can substitute in, check it out. I want you within your small groups to work on D. And we're going to come back together in 4 or 5 minutes. And I'm going to have some of us share it out on the board. And let's get to work.
So you already worked it out. What we told you about.
Well, he's there to participate with you now. He got ahead of you, that's okay. Work on that, I'll come back and check on him. Keep thinking, y'all talk while Sheridan's writing that down.
Exactly. We should have started over.
Why'd you go fly by 2?
Wow.
Okay.
Y'all didn't want to be from trying to learn. Yes.
Okay, so let me ask it a different way. What's the first thing happening to x? Divided by 5. What's happening next? The exponent of squaring. Now, we still have that times 1/2 and that minus 18, but what operation happens first? Multiplication or subtraction? So it's actually x plus 5 squared, then times 1/2, then minus.
Okay, what's the first
The last operation that you want to do first. Okay. There is a way to multiply by 2 first, it's just going to be harder. Come on, Xavier. Hands out your arms. You're super intelligent. You're giving up on yourself. Yeah, but you know you're a senior in high school, right? Wait, you're not in elementary school. Sorry, that's not elementary, that's middle school.
What you need right here?
You're capable of more. Stop selling yourself. Stop selling yourself. Check it here.
I thought it was like.
So what's the first thing you all did?
That's the
Subtract or add? Because you added by 18 first. You multiply by 2. Which one is it supposed to be? Why? Right, the last operation being applied is the first one you want to do. And you can multiply by 2, it's just harder. Okay, by the way, we'll do something else. So, y'all talk about your answer. Once y'all finish up working on it, I want you to put your work up here on the board. We'll talk it through. Okay, man, get engaged in that conversation. Got it? Okay. I want y'all to collaborate. I want y'all to get your answer up here on this board. Okay? How's it going over here? Good?
Does that sound so confusing?
Oh, you got your answers down? Okay, can I get y'all to put your answer in? Like on the board? On the.
You got it.
I'll figure it out one way or another.
It used to be neat, I tried fixing it.
I should allow you to write. Go for it.
Wait,
Y'all, same answer? Not really?
We're trying to figure out where we're gonna separate.
So either way, we can either divide by 2.
Hold on a second. What do you do on the left-hand side though?
Multiply by 2.
So if you multiply by 2 on the left-hand side,
Wait, yeah, I did that. Okay.
should have multiplied by 2 on the right-hand side.
Because that's what I had at first. That's what I had at first.
Okay. Say again? Okay, so you're thinking you should have multiplied by 1/2? Okay. No, you multiplied by 2 right there.
You gotta bring.
No, that's 2 divided by 1 is 2. You multiply by 2. So if you multiply by 2 here, what do you multiply by over here? Right. So multiply by 2 over on the right hand side. Wait, group 2. Why don't we have an answer going up on the board yet?
You making us do D, right?
Yeah, D. Yeah, let's get an answer up on the board. Let's see where we are. Yeah, right, you can write over there. Here, write this blank space.
I got
You guys all confused yet? Go for it. And then you just go from there. I'll get you checked to see if there's a room.
Either way.
I think it's probably exactly square. That might make the difference, right? It's shot.
No, just time for me to copy and paste.
You'll work it out. By the way, don't forget, guys, because Preston's, again, going back to this, you can check your answers very quickly with that calculator. Preston, I'm going to share your calculator, actually.
I forgot what I was doing.
Keep going, sir. How you get 36?
18 times.
Did you put plus 2?
People are about to start going over. Yes, sir.
You said what? Okay. How did I do that?
Like how you put it into the calculator?
Yeah.
You literally just plug it in as is. Jakeem, to finish it, you may need to write some on the right side of that page.
Okay.
But you can, x plus 5 equals, yeah.
You want me to explain?
Now, we move on a little bit. You're talking like those properties equality?
Yeah.
Okay. Okay, so let's look at this together. Two quick things I want to point out. So I think, looking at everyone's, we got 1 and negative 11, is that correct? Yes. In terms of showing a couple of details, I want to emphasize, because Chloe did a great job here, she added 18, so she created what number? 0. But what should we have noted here?
Oh.
So we do want to remember, the whole point is that 2 divided by 2 is 1, right? That multiplicative identity, because when I multiply by 1, I'm just left with that x plus 5 squared. That's kind of the whole point. From there, I think we worked it out very well. We recognized it, and remember when we took that square root, it had to be a positive and a negative, right? And Jakeem, you're getting that up there as well, just writing it really small. Okay. And you can write the solutions above it. Okay. And again, remember, so I'm just sharing Preston's, this isn't even mine. You can substitute it in, right? And just write it as is and test it out. Now, Preston, you kept getting frustrated at first, right? Originally, Preston had it written as this, and it was giving him error, or no, it was giving you false, right? Which, negative 11 definitely is a solution. Be careful when you're typing it in, because what was he originally missing? The square, right? It's a very simple correction to get that square in there. Are there any, what are your questions, comments, or concerns before we continue forward? Okay. Now, what I want to point out, because this is actually going to show up in the next part of this lesson, not right now, but in the next part, this right here. Does that look familiar? Like one of the forms of a quadratic? Vertex form, right? And so you want to hold on to this for the future. When you have vertex form for a quadratic equation, what's the easiest way to solve it? Just use your what? Say it again. That is not what we did. We did not just use the calculator. What did we use? We used our inverses with it starts with a P, it's a property of equality, right? We need to recognize, right? When I have that vertex form, I can just use properties of equality to solve that equation. But we're going to look at a slightly different method right now. Actually, I do want to pause and point something out. You see how this is equal to 0?
Right.
Right? Yeah? So if this was, I don't know, a function, I really wish I had pointed this out first block, I'm just now noticing it. If this was a function and it's set equal to 0, our solutions here might be called, they would be x-intercepts, but it's set equal to 0, so we could call it a root or 0. Remember, it's set equal to what again? 0. Okay, yeah. So how could I use, and I one size like Preston used a calculator to substitute it in to tell it was true. How could we use the calculator in a graphing feature to determine if those solutions were correct? Say again? Yeah, could I graph that function? Yes? What should I see at 1 and negative 11? Well, I mean, I should see a quadratic function in general, but... Okay, so let's check. 1/2, was it x? What was next? Minus 1 squared minus 18? Well, I'm trying to do this off memory. Help me out. Oh, 5? Y'all. I completely misheard you. My bad. You know, ears, they sometimes work. Alright, so I'm going to zoom standard. Okay, so I see the 1 there. Do I know that's a negative 11? What can I go to under analyze graph? Because I don't want to count this. I'm going to go to 0. Oh yeah, that's right, it's a 0. Ah.
Wow.
Look at that, man. Technology is so beautiful, y'all. We don't have to get stressed about the whole algebraic part, Jaquan. We can use graphs to help us out and check our answers, all right? Also, hey, I want to point this out. I am asking you to learn how to solve these equations algebraically. But if you use a graphing calculator, and you can explain how you use that graphing calculator, do you think that shows me some level of understanding?
Yes, it does.
It does. Use technology to your advantage. Use your thinking. I care more about mathematical thinking than just memorizing and mastering just pure content. So yes, you can solve these equations in other ways. Keep that in mind. All right, but let's continue this lesson focusing on this next part. Because number 2 here, right? Oscar used a very different strategy for part A. What did we do at this point? We had a 9 to both sides, right? So we could then take the square root. What did Oscar do? Hey, that dude subtracted 27. Okay, first off, why did he subtract 27? To create what? 0, right? So it's the additive inverse, so he created a 0. Now, that equation looks different, right? Is it completely different? It's still equivalent. He used the property of equality. This is acceptable, right? Say again. Oh, he got to standard form. Notice, right, standard form we said earlier was ax squared plus bx plus c. We just need to recognize that the b, since it's not there, must be a 0, right? The only reason we won't have to write is because it's a
0.
You with that, Mark? You zoned in, focused? Sure? You are now, right? Okay. So standard form, we have that. But he just did something a little different. He went to factored form.
That's smart. That makes sense.
So I'm going to cover 2 different things right now. First off, I'm going to talk about why would he want factored form. And secondly, I'm going to teach you how he got to factored form. So does anyone have an idea why he might want factored form when paying attention to what he did next? It's something about those zeros. There's something really important about that 0. How in the world did he go from this equation to these 2 equations? He didn't take a square root. There's no square root symbol there. It's in factored form, but how did he go from one equation in factored form?
Because it's too linear. What do you mean?
Okay, so let's pause for a second. Let's pause for a second, we're gonna come back to it. Let's say 6 is equal to x minus 6 times x plus 6. Can I then say 6 is equal to x minus 6?
He said them both equal to 0.
Well, but, right, well, hold on. Okay. In that same vein, right, you're saying he said them both equal to 0, but it's because it was equal to 0.
Yes.
Can I then split this into 6 equals x minus 6 and 6 equals x plus 6?
Yes.
Yes, you think so?
Yep.
Okay, let's check it. Let's add 6. 12 is equal to x, right? Substitute that in. What's 12 minus 6?
6.
Times 18? Is 6 times 18 going to equal 6?
No.
So I can't just magically split up my factored form every time I want. And take a square root. There's not a, look, remember, to take a square root I need a square. I don't have a square.
Zero product property.
Say it louder, Preston.
Zero product.
That zero product property that we studied last unit. You remember that detail?
Yeah, we remember.
What does that mean, Kiani?
One of them
Oh, I don't
equals zero.
remember.
A plus B plus
One of
C
them
equals
equals
0.
zero.
One of them is equal to 0.
Not A plus B plus C.
One of the factors equal to 0.
Oh, remember.
Each one.
Look, no, you're doing well, but we gotta learn from our mistakes. Remember, if I have A times B is equal to 0, right?
Mhm.
Well, if A times B is equal to 0, at least one of the factors has to equal
Zero.
0. If I have A times B, right, equals 6, I mean, that could be 1 times 6. That could be 2 times 3.
But it's not
That
zero.
could be 3 times 2. That could be 6 times 1. You see how many different combinations there are when the two factors equal 6?
Yes.
But if it's equal to 0, one of them has to be what?
Zero.
0. That's why are you looking at me like that?
For me?
I'm going up for my friend.
Oh, okay. Okay. You looked at me like, you're, oh, Mr. Kinney, what did you just say? Okay. So I need y'all to understand, when I go to factored form, it does not help unless that factored form is equal to,
Zero.
okay, and why do we need it equal to 0? Because of what property?
Zero product property.
Right. I would make a note to yourself, factored form has to equal 0. So, we can use what? One person who says, Xavier, do you know what property we're using? The answer is no, man, that boy's out cold. David, what property are we using? Zero product property, Mackenzie? Zero product property, Keyshawn?
Zero product property.
Alright, so we can use the zero product property. Me too, man. All those students trying to not do work is killing my head too. I appreciate you. Alright, so this is why, right, we're trying to get factored form. This is the why we're doing it. So we can use that zero product property. But now we need to figure out how to do it. Now, one thing I want to point out is, how could I check? There's two ways, really. How could I check to see if my factored form is correct?
Put it in the calculator.
Okay, what do you mean by put it in the calculator?
Graph it.
Okay, because what are we going to look for when we graph it? The x-intercepts. Remember, I could check to see if those are the roots of that function. That's a great way to do it. So let's check to make sure Oscar did this correctly.
Who said that? Just they don't like it.
Please hear me very clearly. I'm not showing you. I'm going to have someone else
Lazy.
showing their works. I need you to turn on your calculators.
Why is it not working? You don't want to see us.
I want to see you.
Thank you. You look tired.
Just kidding. I apparently cannot capture the class for some reason. I know, you're so excited. All right. Well, I'll have to show it. Bummer. So, what's the function I should type in? What's the function I should be typing in to check to see if that factored form is right?
27 is a squared minus 9.
I don't think that's what we factored, was it?
Oh, x minus 6 times x plus 6.
Well, that's already the factored form, right?
What you say?
Oh, the x squared minus 36. Remember, that standard form is what I started with to get my factored form. I'm checking to see if my factored form is correct. So let's find those zeros.
Stop being lazy.
Did you say stop being lazy and count it out? It's not being lazy, that's using it in technology. Ah, is that factored form correct?
Yes,
sir.
Okay. So first off, I want you to notice, once you factor, you can use a calculator to check to make sure your factors are correct. The second thing to remember is this. What did we do last unit to go from factored form to standard form? Didn't we distribute? Do you think I could distribute here to check? Okay. This is where I want you to get out that blank sheet of paper and I want you to start taking some notes. If you're already taking notes on a blank sheet of paper, continue. But you need to box this statement. So, factoring quadratics notes. What'd you say? You ain't ever had me just do direct instruction like this before. I agree. Xavier doesn't even know what to do. Okay.
Oh, sir. Mr. Owen. Oh, sorry.
No, I'm not cold. I'm sorry. Okay? So. Will I turn off the air? The answer is no. Sorry, buddy. Alright, so here's one of the things I want you to understand first and foremost, right? I'm going to start by looking at the idea of distribution to help us factor. Alright, so background to factoring. That's what we're writing here first. So this is the background to factoring. We did this last unit. To go from factored form to standard form, you could either use the area model or what else could you do? Distribute. To help with this unit, I'm going to focus on distributing. And we distribute to get what form?